Okay, Brad, I've completed your inspection and I'm glad to say we found you a solution. So I'm going to be talking about permanently stabilizing your walls. But before I do that, a lot of our homeowners really appreciate understanding what caused these problems and how they found themselves in this position to begin with. So, to better help answer those questions, I have a few short slides here that I'm going to share with you just to help give you a better understanding and a better visual as to what causes wall failure, okay? Okay. So, essentially, when your home is first constructed, your foundation consists of three main parts. You have your footing, you have your concrete floor, and you have your foundation wall. Now, these are all constructed and poured at various times to allow that concrete to properly cure, and in turn, it's going to support the weight of your home above it. And then, what we're working with here are two main soil types. You have compacted virgin soil, which gets naturally compacted over time through hundreds, if not thousands of years due to the environment. Essentially, that soil hasn't been touched, and it's also really stable. Then we have something called loose backfill soil. Essentially, what that is after your foundation is complete, contractors will push in all that loose backfill soil to then fill the void of which they originally excavated to complete the foundation. Okay? Now, the problem with that loose backfill soil is it's not properly compacted to begin with. So, what that's going to lead to is something that we call an active wedge or unstable soil. And the problem with that unstable soil is it weighs thousands of pounds. So it's exerting a lot of force and a lot of pressure on your wall, causing it to fail. And then when we move into the wet season or have a heavy rainstorm, water likes to follow the path of least resistance. So essentially it's going to trickle down through that unstable soil and cause something that we call hydrostatic pressure. Now, to put into perspective, water weighs anywhere from 8 to 9 pounds per gallon. Now, that is a lot. Honestly, I was really surprised when I heard that too because I wasn't expecting it. And then in the winter months, what do you think might happen to that water? You're exactly right. It's going to freeze. And not only is it going to freeze, it's actually going to expand at about 9%. So when you have the expansion and freezing of the water, you have the hydrostatic pressure from the water, and you already have that unstable soil, it's going to cause a lot of exerted force and a lot of exerted pressure to cause your foundation wall to fail. Okay? And I'm going to stop right here because I just want to ask, is all this tracking so far? Okay, well, I'm glad to hear that. Please feel free to stop me at any time if you have any questions because I just want to make sure this is all making sense, okay? Awesome. All right, so leading into it, we have the four main stages of wall failure. So first, we have horizontal cracking, which essentially is just a horizontal line across your foundation wall. After that, we have something called stair-step cracking. And telling by this visual, can you tell me why they're called stair-step cracking? You're right, yeah, because they look like stair steps, right? After that, we have something called tipping and shearing. And essentially, that's the wall bowing or falling inward towards the foundation of your home because it can't support the weight of the soil behind it, okay? And then lastly, what do you think the last stage of wall failure might be? You're exactly right. It's going to be complete wall failure. Now, as I already mentioned, I've completed your inspection. I just want to preface this. You're not at this stage yet. However, I do want to bring this up just because it can become an issue if not properly addressed. Okay? So, you might be asking yourself, well, Connor, what are my options for repairing, right? So, historically, there are three main options for repairment. You got do nothing, you got do it yourself or DIY, you got hire a contractor. Okay? So, if we do nothing, what do you think might happen? You're right. It's just going to get worse, right? And as Isaac Newton put it, an object that's in motion tends to stay in motion. So this problem is just going to get worse with time, okay? Next, we have DIY or do-it-yourself. And look, I know in today's age, YouTube University has a wealth of knowledge. However, in most homeowner cases, they don't have the proper expertise, proper materials, or proper equipment to handle a foundation problem like this, okay? So as I mentioned before, we're a specialty contractor and we deal with thousands of these projects every day, okay? And lastly, what you could do is hire a contractor. Now, with contractors, I like to say they're a jack of all trades, but a master at none, all right? And essentially what they're just gonna do is just subcontract somebody else to come in and do a full foundation replacement. Now, the problem with this is it's expensive, it's time consuming, and it's invasive. Okay, essentially what they're going to have to do is dig around the perimeter of your foundation and rip out any utilities in the way. I'm talking HVAC, plumbing, that brand new patio that you just put outside, that's gone. That's gone. Okay? And they're gonna just rip out that older plate or that old foundation, jack or crib up your home and replace it with a new one. Okay? However, as I mentioned, it is expensive and it's also really time consuming too. Typically, a foundation replacement can take up to 60 days because you're allowing the footing to properly cure, and then you got to build the foundation and allow that to properly cure. So, do you want to be out of your home for 2 months? Hey, I wouldn't want to either, right? So, I think it's safe to say, or can we agree that none of these options are the right solution for you? Awesome. Well, I'm glad to hear that. So, that's going to lead into our solution. So what we have to offer here at Groundworks is something called a settle stop wall anchor, okay? And right here. All right, so our engineering department put together this short video clip that explains this at a very high level. Once we finish this, I'll go ahead and dive in a little bit deeper to help give you a better understanding of how the installation process occurs and what this whole system is about, okay?
When the walls that support your home begin cracking, leaning, and bowing, you may begin to wonder, is this house safe? Unstable walls can create doubt and concern for both homeowners and home buyers alike. When basement walls become a safety concern, the Settle Stop Wall Anchor system is the answer. Each Settle Stop Wall Anchor consists of a galvanized plate that's connected to an earth anchor with a high-density 1-inch steel rod. The wall anchor is tightened to combat the forceful soil pressure, which commonly causes walls to fail. The Settle Stop Wall Anchor system is durable, minimally invasive, and can be installed in as little as 1 day. The installation is straightforward. First, a small excavation takes place approximately 12 feet from your foundation wall. Next, a 1-inch hole is drilled through the basement wall. Then, the 1-inch steel rod is driven to the excavation point outside and attached to the heavy-duty earth anchor. And once in place, the steel plate is mounted on your wall and then tightened to the engineered specified torque reading. Your basement wall is now anchored in dense, stable soils. The Settle Stop Wall Anchor system is great for customers who want immediate stabilization and adjustability over time. The low-profile wall plates fit between wall studs and are ideal for future basement finishing. The Settle Stop Wall Anchor system is backed by a lifetime transferable warranty, so there's no need to worry about the structural stability of your foundation wall. We'd rather have you focused on the more important things in life.
Pretty cool stuff, huh? So to take a little deeper dive, real quick, here's a visual representation of what this system looks like, okay? And as you mentioned before, this is commercial grade galvanized steel, so it doesn't rust and its structural integrity is really strong, okay? So essentially what we're gonna do is we're gonna measure for the anchor locations using engineered spacing. So we're gonna come 2 feet in from the corners and then 5 feet on center after that. From there, we're gonna drill about a 1-inch hole into the foundation wall and insert the galvanized rods into a 10-degree angle. The reason that we do this is so that we prevent any water seepage coming into your foundation. Then from there, as he mentioned, we're gonna excavate a site 12 feet approximately from your foundation wall. And this allows us to add on that earth anchor plate. So to put this in a better perspective, think of like a vise. As you tighten it and tighten it and tighten it, it becomes closer and closer and closer and just creates better stabilization, right? So that's essentially what's happening here with this wall anchor system. Excuse me. And then from there, we're going to tighten it to the engineered specifics. And essentially all we're going to do is just put that soil back and it's like we were never there. So, so after reviewing this, does this feel like an option for you? I'm glad to hear that. Let me add a few of these to the cart and I'll get started on your proposal, okay?